Hello, everyone, and welcome back. My name is Mr. Kovalt, and in this video, I'm going to go over how to identify what the conjugate acid of a given species is. So let's get into this. So the first thing I want to understand is what's the relationship between your acid and its conjugate base, and its base and its conjugate acid. So the difference between them is going to be the transfer of a hydrogen between them, right? The first thing you got to understand that when we identify an acid or a base, that's going to be in the reactant side. So whatever's on the reactant side is going to be identified either as an acid or a base. And then anything on the product side of your reaction is going to be identified as the conjugate acid or the conjugate base. So here we have a list of substances, and they're asking us here, what is the conjugate acid of these things? So I'm going to first write an equation with the reaction of water to identify or demonstrate what I'm referring to. So let's take fluoride ion here, and we want to identify what the conjugate acid of the fluoride ion is. So we're going to write a reaction where the fluoride ion is reacting with water, right? So here we have the fluoride ion, and that's going to react with water. And so fluoride ion is the anion of a weak acid. And so because it's the anion of weak acid, it will react with water to take back a hydrogen. And so in this case, it will take a hydrogen from water and reform the weak acid HF, and you'll end up with OH minus. And so remember the definition, the Arrhenius definition of an acid is that something that increases, or I should say the base, is something that increases the hydroxide ion concentration. And so here we have that happening here. So the fluoride ion acts as a base in this situation here. So you'll notice that here this will be the base. So this would be like your Bronsted-Lowry. Oops. Sorry about that. So if you remember the Bronsted-Lowry definition of acid base, it has to do with being a proton acceptor or being a proton donor. And remember, what we mean by a proton is H plus. So if you are a proton donor, you're gonna be a Bronsted-Lowry acid. If you're a proton acceptor, you're gonna be a Bronsted-Lowry base. So in this case, the fluoride ion is behaving like a Bronsted-Lowry base because it is accepting a hydrogen or H plus from the water. And in this case, water is acting as an acid, a Bronsted-Lowry acid, because it is donating hydrogen to your F minus. So in this case, the fluoride ion is the base. Your water here is the acid. Now, the distinction or the relationship between your base or acid with its conjugate is by the fact that they are related by the exchange of one proton, right? So here you have the base for the fluoride ion, but if you add a hydrogen to this, then you get HF. This is going to be the conjugate acid of this base. And you can see that they differ by the transfer of a hydrogen. If I transfer a hydrogen to water, right, then I would have F minus. If I transfer an H plus to F, then I get HF back, right? So there's a difference of one hydrogen between these two. So these two are conjugate, these are the base conjugate acid pair, and this is the acid, and this is the acid conjugate, this is the conjugate base pair. So we have the base and the conjugate acid paired together. we have the acid and the conjugate base paired together. And notice that the water and the hydroxide ion, they differ by the transfer of one hydrogen. If you go this way, you're transferring a hydrogen away from the water to form OH. Going this way, you transfer it back to the OH to get the water. So that is how you identify what the pairs are between the base and the conjugate acid and the acid and its conjugate base. So you'll notice here that if we're given these substances and they're asking for the conjugate acid, it's always going to be the case that the conjugate acid is going to be formed by adding a hydrogen to the species you're given. Because remember, the conjugate acid comes from a base. So we got to treat these as bases. What do bases do? They take protons. So by taking a proton, you are producing the conjugate acid. So I just wanted to kind of go over that as a backdrop to how I'm going to do this. So the conjugate acid of this is going to be HF because I'm adding a hydrogen to my fluoride and I get HF. So there's the conjugate acid of this. Now, this acts as an acid because HF can give away its hydrogen and then act as an acid to reform the F minus. Okay, so then what about this ammonia? So ammonia can react with water, take a hydrogen away from ammonia, and it'll form the ammonium ion. So you add a hydrogen to this, and you get NH4 plus. So that's the conjugate acid of this base. HSO4 can react with water, take a hydrogen away from water. And so I'm going to add a hydrogen to this formula, and it becomes H2SO4. Same thing here. I throw this in water. It can take a hydrogen away from water. And so I'm going to add hydrogen to this, and it becomes HCrO4 minus. So I go from the chromate ion to the hydrogen chromate ion. Now, what I want you to see at this point is I'm only adding one hydrogen. So I add only one hydrogen. So the difference between your base and its conjugate acid is just one hydrogen. So if I go to the next one, NO2 minus, I add a hydrogen to that because it's going to take a hydrogen away from water when you throw this in water. So it's going to be HNO2. So that's the conjugate acid. So here I have the hydrogen carbonated ion that will take a hydrogen away from water. So I'm going to add a hydrogen. So that's going to give me my carbonic acid. Next, I have water. Yes, water can act as a base. And so in this case, water can take a hydrogen away from something. It can take a hydrogen away from another water. That's called the autoionization of water. So in that case, it would produce the hydronium ion. So that would be the conjugate acid of this base. And then finally, we have PO4 minus. So that is going to take a hydrogen away from water. And then so I add a hydrogen to that formula, and it's HPO4 minus. And so that is how you find the conjugate acid of a given base. And so I hope this was helpful. If you like this video, then please by all means like, share, and subscribe to my channel. So hit that like button over there. When you subscribe to my channel, make sure you hit that notification bell. And when you do, make sure you click all so you can be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem or a question you want answered, or if you have a topic you want me to cover, then please let me know. I would love to do that for you. Thanks for joining me, and have a great day.